Hello guys, good evening. How are you? I hope your preparation for the exam is going very good. My today's talk is on important topics and important questions of electrochemistry. This is a very big topic and there will be a lot of numericals which are expected from this. And you know that the minimum marks for the numericals is about 10 marks. And we are going to get definite numerical from this. And this will be 100% based on the NCERT questions which are already there in the book solved as well as on the back of the book. You must do that. In the electrochemistry, you can see that there it is a totally 5 marks, essay 1, 2, 1 and essay 2, 3. So total 5 marks for you. First thing you will see galvanic cell or electrochemical cells which can convert chemical energy into electrical energy. The first thing I am talking in this is a Daniell cell. You know that Daniell cell is nothing. You have reduction half cell reaction, copper 2 plus aqueous is copper, and you have oxidation half cell reaction. This is called the net cell reaction. And as I write, the symbolic representation is very important. How do we represent? In left hand side, cathode is on the right hand side, and there is a salt bridge in between the two. Salt bridge is important to complete the circuit as well as in order to make the cell run continuously. Otherwise, there will be accumulation of charges on either side of the electrodes and reaction will stop. We know that the E cell, how to obtain E cell is very important. The numericals will be asked of that. Is E right minus E left? And here I am using standard values, standard electrode potential. As you can see, is E right minus E left. For example, for the Daniell cell, the standard reduction potential values are given in electrochemical series, and they will be given in exams also to us. And we have E right minus E left. It is coming to be 1.10 volt. This is the standard value of the cell electrode cell potential for the Daniell cell. As you can see that anode is written on the left hand side, salt bridge, cathode is written on the one numerical is expected on this. Further, we know that it is not possible to determine the absolute value of the half cell. Therefore, we always make join two half cells, and what you get is the cell potential. And in order to calculate the standard electrode potential values or standard reduction potential as per IUPAC notation, we are using standard hydrogen electrode, and I have given a representation of standard hydrogen electrode which you already know in the book. Platinum S, because hydrogen is a gas, 1 atmosphere, and H plus aqueous 1 molar solution of acid is taken, and this is arbitrarily assigned a value of 0.0 volt. You already know that, and this is the representation. I am always representing standard electrode potential is same as standard reduction potential values which are given in the electrochemical series, in which we have arranged the elements or according to increasing or decreasing values of their standard reduction potential values with respect to standard hydrogen electrode. And here most important thing, that question is always asked is on Nernst equation, because when we use standard values we are using 1 molar concentrations, and at 298 Kelvin these measurements have been performed. If we have different concentrations C1 and C2 of the electrolytes, as you can see here, for zinc ion I am giving concentration C1, and for copper 2 plus, then Nernst gave a mathematical formula which is very important. Nernst equation is very important for finding the values of the cell potential at any given concentration. For one half cell, Mn plus N is equal to Ms. In the NCERT book you will find EMN. This is the cell potential of the half cell. This is the standard value of the cell potential, RT by NF. Ln, the metal solids are taken as unity, and this is the concentration of the electrolyte which we are using, and this formula turns out to be EMN, Mn 0.05 divided by N log of 1 by Mn value for half standard for half cell. For the general reaction, AA plus BB is equal to CC plus D, I am writing E cell is equal to E standard value of the cell potential minus RT NF Ln Q is the reaction quotient, or I can convert these values into C power C, D power D, A power A. In terms of log, these formulas are given in the book, you must do them. There will be numerical on Nernst equation. Always a numerical is given, and numerical will be based on NCERT, all in-text questions, solved question, and on the back of the book must be solved by the students. Now I am talking of another important questions which will be there. What is the relationship between equilibrium constant and standard cell potential? As you can see, E naught cell is equal to minus 0.059 by N log of Kc. From here we can find the values of equilibrium constants which are otherwise difficult to obtain. So this is a very good application, and here I am giving EMF and Gibbs free energy relation for the reaction delta G. Standard value of the delta G is related with the standard value of the cell potential. You already know that Gibbs free energy for a reaction which is spontaneous should be negative, and that means E cell should be positive. Standard value of the E cell should be positive. And another formula I am giving, delta R is equal to minus 2.3 RT log Kc. And here a numerical was asked last year. There is a possibility that numerical can also be asked this year also on this based on NCERT books. Now further I am coming to conductance of electrolytic solutions. Here what is important is the formula R is equal to rho L by A. Conductance is equal to 1 by R, and conductivity is very important. Conductivity and also the cell constant SI unit of conductivity. So you can see Simon per meter inverse, and but since meter is a very long length, therefore most of the time we are using Simon centimeter inverse. And there is a relationship between cell constant and resistance and conductivity. Very important relationship, as question has been asked in it repeatedly many times. Now I am coming to the most important questions also. Molar conductivity. Molar conductivity is related with the conductivity by the volume V for one volume V by this formula. This is very important formula which I have given, which will be useful for the solving the numericals. But make sure you use the right units. What are the units of molar conductivity has been asked many times. Again I am talking Simon centimeter inverse, mole inverse, and if I put the right units, the formula becomes conductivity into 1000 centimeter by liter divided by polarity is always in moles per liter. So this formula is very useful for solving numericals. There will be there in the board paper usually asked. Variation of conductivity with concentration of electrolyte. We already know that conductivity always decreases with decrease in concentration because the number of ions per unit volume decreases. But variation of molar conductivity with concentration of electrolyte increases with a decrease in concentration or dilution. I have shown a graph also which is given in the NCERT book. This is very important because weak electrolytes, you see there is a steep rise on dilution because the ionization of weak electrolyte is incomplete and more ions are produced when we dilute the solution. For strong electrolyte, as you can see the graph, the increase is small because the strong electrolyte is completely ionized, only there is an increase in ionic mobility on dilution. So there is a small increase, and for strong electrolyte this equation lambda m is equal to lambda 0 m minus AC 1 by 2, very important equation. What is limiting molar conductivity? When the concentration approaches 0, the conductivity is known as molar conductivity. Limiting molar conductivity can be obtained graphically for a strong electrolyte, but cannot be determined for a weak electrolyte because as you can see the graph, the value cannot be measured. So in order to determine the molar conductivity of weak electrolyte, we use Coleridge law of independent migration of ion. Very important question, numerical can be given based on NCERT book. Again I am saying Coleridge law of independent migration of ion. I have expressed it V plus number of cations, V minus anions, then the formula is lambda 0 m, V plus lambda 0 plus V minus lambda 0 m. What is the importance and application of Coleridge law is that for weak electrolytes we can calculate the degree of ionization by using lambda m by lambda 0 m, and also we can find the dissociation constant of weak electrolytes. Very important numerical, very important numerical. Now I am coming to electrolytic cell. When we apply external current, chemical reactions take place. This was studied by Faraday, and you know that Faraday has given two laws, that the amount of the substance deposited at electrode is directly proportional to the quantity of charge passed. Here first law, W is equal to Z and 2I into T, where Z is electrochemical equivalent and E is second law, W1 by W2 is equal to E1, that the amounts of the different substances deposited or liberated at the electrode are proportional to their equivalent masses. Equivalent mass is molecular mass divided by the valency of the cation, as you can see. Further, there is a question on products of electrolysis, very important, that when we do electrolysis of aqueous NaCl, what are the products? Here the products are chlorine and hydrogen and NaOH. I am saying at cathode the value which has higher E standard deviation is preferred, and at anode the value which is lower E0 standard potential is preferred. So according to that we can find out the products, but there are exceptions whenever there is a question of overpotential. So we have to be very careful, read the NCERT book very clearly what is overpotential. Now I am coming to the batteries. You can see that there are two types of batteries which we are using. Primary, they cannot be recharged. Secondary can be recharged. Dry cell is example of this, and lead storage battery is example of this. Here you have to study anode, cathode, the reactions as they are given in the NCERT books. They are important, and other type of batteries which are there also you have to study what is anode, what is cathode, the electrolyte used, and what are the merits and demerits of each of the battery which we have to use. Then I am talking of fuel cells are very important, which were used in the Apollo spacecraft, hydrogen and oxygen. What are the advantages of the fuel cells? How they convert fuel into electrical energy? Most important question is coming on corrosion, that show that that corrosion of iron is an electrochemical process. Here equations have been given in the book in NCERT. You must know the equation and Nernst cell reaction, and also methods of prevention of the rusting of iron are important this year. Now I am going to read some important questions based on electrochemistry. First question is, what is conductivity? What is molar conductivity? What are the units of molar conductivity? Very important units of molar. What is Nernst equation? Write the Nernst equation for the linear cell. We have already given you. Why it is not possible to determine single electrode potential? Because half cells cannot exist independently. You need another half cell in order to use that. That is why we used standard hydrogen electrode. Name the factors on which EMF cell depends. Nature of electrolyte, temperature and pressure of the gas. What is the electrochemical series arrangement of different elements in increasing or decreasing order of their reduction potentials? Explain that rusting of iron is an electrochemical process. The equations are given in the book, you will have to write. What is standard hydrogen electrode and what is the significance? Again, you know that hydrogen gas platinum electrode, 1 molar HCl, and the symbolic representation I have already shown. What is electrolytic conduction? What are the factors on it? State and explain Faraday's laws of electrolysis. What is electrochemical equivalent? We have already shown you. State questions. Write Nernst equation for a single electrode. We are already written. They can ask you for a linear cell or anything. Depict a galvanic cell. Some equation is given, copper plus 2Ag plus gives 2Ag Cu2 plus. You have to show the symbolic representation of the cell. Important. What does the negative sign E0 Zn2 plus Zn shows? This value is minus 0.76 volt. Zinc is more reactive than hydrogen. Zinc will displace hydrogen gas from the acid. What is limiting molar conductivity? Very important. When the concentration approach unity, the ions move independent of each other, and that is what we call as the molar conductivity is equal to limiting molar conductivity. What is the difference between primary cell and secondary cell? You know that one primary cell will become dead over a period of time. Secondary cells can be recharged. Compute the charge of 1 mole of the electron. 1 mole of electron, 1.6 10 minus 19 coulomb is the charge of minute. 1 electron multiply with Avogadro's number, that is what comes to be 1 Faraday, 96,487 coulomb. Very important. Express the relationship between cell constant, resistance of the cell, and conductivity of the cell. Already shown. This is a very important question. Even numerical will be there based on the NCERT book in this. What are the units of conductivity and molar conductivity? Again, I am talking of these units, very important. Express the relationship between molar conductivity and conductivity. I have given already, and I have expressed the units because here students do mistake in numericals. Centimeter or meter, you have to be very careful of the units. What is cell constant? What are the units? Again, very important. What is molar conductivity and its units? Again and again, I am repeating the same question. And as you have seen the graph, why the behavior of strong electrolyte and weak electrolyte is different in terms of dilution on molar conductivity is an important question. Write overall reaction for the lead storage battery. Lead storage battery which is rechargeable from the NCERT book. Check the equations of anode, cathode and the net cell reaction. Write the chemical reaction for rusting of iron and one method of prevention of rusting of iron. Very important question for this year. These equations are given in the NCERT book. Must do it. What are the advantages of fuel cells? They are more efficient, pollution free. Further solution, A and B diluted. Lambda M for A increases 2.5 times, B 25 times, which is strong electrolyte. You know, for strong electrolyte, the increase of molar conductivity and dilution is less. Further, why conductivity of solution decreases with dilution? Because the number of ions per unit volume decreases. What is nickel cadmium cell? Merit, demerits over storage cell. Nickel cadmium is a secondary cell, rechargeable, longer life than storage but more expensive. Give reason why alkaline medium inhibit rusting. Because rusting of iron takes place in the presence of H+. Why zinc is used for protection of rusting of iron? Because zinc undergoes sacrificial oxidation and is more reactive than iron. The reduction potential of zinc is lower than Zn2 plus Zn is lower than Fe2 plus Fe. Why does dry cell become dead after a long time even if not used? Ammonium chloride is a salt of weak base and strong acid, therefore it will corrode zinc. Give the formula for the calculation of equilibrium constant and E relationship. We have already given. Give relationship between conductivity, conductance, or we have already given. Very important question. Very important question. How much charge is required to reduce 1 mole of aluminium 3 plus ion? Aluminium 3 plus ion, according to Faraday's law, will need 3 moles of electrons, so 3 Faradays. Predict the products of electrolysis of aqueous solution of silver nitrate using platinum electrodes. Very important. Products of electrolysis can be asked you in the exam. At cathode, silver will be reduced and give silver. At anode, OH minus undergoes oxidation and you will get oxygen gas. As I said, the value of the electrode potential value which is higher will be reduced preferably, and one which is lower will be oxidized at the anode. So, how much electricity of Faraday is required to produce 40 gram of aluminium from Al2O3? Aluminium plus 3 gives 1 mole of aluminium, which is 27 grams. So, 27 gram of aluminium will give you 3 Faraday. Then how much will be 40? It will come to be 4.44 Faraday. How many coulombs are required? 1 mole of water, 2 oxygen. You know water is being oxidized to oxygen and 2 electrons are released. So, 2 Faraday, 2 into 96,500 coulombs. Predict if the reaction between Fe3 and I minus are feasible. If Fe3 will be converted to Fe2 plus, so Fe3 plus is reduced, I minus is oxidized to iodine, and E0 for the cell is plus 0.230. It is positive, therefore the reaction is feasible. Predict the products of electrolysis of dilute sulfuric acid. Platinum electrodes are inert electrodes, they will not be attacked. At cathode, H plus E will give half hydrogen. At anode, OH minus will be oxidized to give you oxygen. Therefore, hydrogen gas will be there at cathode, oxygen gas will be there at anode. These are some of the important questions. What type of battery is mercury cell? What are the advantages of dry cell? So, here you already know that primary cell are not chargeable. What is the difference between primary and secondary battery? We have already said that storage battery is and nickel cadmium, they are examples of the secondary batteries. Further, a solution of nickel nitrate is electrolyte between platinum electrode using a current of 5 amperes for 20 minutes. What is the mass of nickel deposited at the cathode? So this is a question numerical. As I said, the numericals are based on NCERT book and based on Faraday's laws. You have M is equal to Z into I into T is an important formula. The mass of the substance deposited is equal to Z into I into T. This formula is important. You should keep with it. This is the formula. W is equal to Z into I. So this is the mass of the substance which is deposited. Z is my equivalent, which is equal to molar mass divided by the valency. I is the current in ampere, T is the time in the second. This such a question will be there. Why does conductivity of solution decrease with the dilution? We have discussed why it decreases with dilution. Resistance of 0.01 molar NaCl at 25 is 200 ohm. The cell constant of the conductance cell unity, calculate the molar conductivity. So relationship between molar conductivity we have already shown to you. We can apply the formula and you can use NCERT book for solving such numericals. Again and again I am saying that numericals will be based on NCERT book. It is not possible for me to derive all the numericals here, but I am giving you hints that you can look up the NCERT book and do all the in-text questions and on the back of the questions. Set up Nernst equation for dry cell, show that the voltage of dry cell has to decrease with use. Because in this, if you will set up the equation of the dry cell from the NCERT book, you will find ions are involved. Whenever ions are involved, then voltage will decrease. So due to presence of ions in overall reaction, its voltage decreases. Define the fuel cell. Chemical energy is converted into electrical energy. Hydrogen and oxygen is the fuel cell which has been used. Then calculate delta G for the reaction. E0 cell is given. In such delta G, Rg is equal to minus NFE formula, which I have already given. Such numericals will be there. Write two advantages of fuel cells. You already know efficiency and does not create pollution. Then there is a relationship between NFE0 and Kc. There could be a numerical based on that. Important. State and explain Faraday's laws of electrolysis. You already have done it. Calculate the EMF cell at 298 Kelvin using Nernst equation. This is a numerical. Magnesium solid to magnesium 2 plus 0.1 molar. Salt bridge copper 2 plus 0.012 copper. So you are given the standard cell potential value. Use the Nernst equation. Very important numerical will be there on Nernst equation. Again and again I am saying. So find the minimum potential difference needed to reduce Al2O3 at 500 degrees centigrade. Delta G is 960 kilojoules. So here delta G is equal to minus NFE0. This formula I can apply. This value is given. Therefore, I can find the value of the E0 standard cell potential for the given reaction. Calculate the EMF at 25 degrees centigrade. You are given cell symbolic representation of the cell: silver, solid to silver, aqueous 10 minus 3 molar, salt bridge, copper 2, 10 minus 1 molar to copper. E0 cell standard value is given. Nernst equation, apply and solve the equation. Nernst equation, again I am saying, is important. A one numerical is coming on Nernst equation. Usually it is asked. The resistance of a conductive cell containing 10 minus 3 molar KCl 25 degrees centigrade 15 ohms. What is the cell constant of the conductivity if 10 minus 3 molar KCl at 25 degrees centigrade is 1.5 10 minus 4 centigrade. Such numericals are given in the NCERT books. Conductivity is equal to 1 by R L by A, and L by A is the cell constant, so you can determine the cell constant and apply the formula. So what type of battery is lead storage? Right anode and cathode reaction. You already know that this is a secondary cell, and lead plus sulfate ion gives lead sulfate to E, lead O2 sulfate to H2SO4. Lead NCERT book, you can use the equations and find out. Express the relationship between molar conductivity and conductivity. Very important. Again and again we are using lambda m is equal to 1000. Conductivity divided by molar conductivity. Units, you have to be very careful of the units. Determine delta G0 and Kc when E0 values are given. These are the numericals, important numericals. They can be asked again. Explain corrosion of iron is electrochemical process. Very important question. We have to write the equations of the iron and net cell reaction which are occurring. Reactions occurring at cathode anode during the mercury cell. So zinc mercury amalgam anode, a paste of mercury oxide, cathode electrolyte QH. At anode, zinc undergoes oxidation. At cathode, mercury oxide gives mercury. The net cell reaction. Use NCERT book to find these type of questions. They are important. Calculate the degree of dissociation of acetic acid at 298 Kelvin. Molar conductivity 11.7, and molar conductivity, limiting molar conductivity, acetate ion is given. Limiting molar conductivity H plus is given. So therefore, alpha is equal to lambda m by lambda 0. M is a very important question. Very important question of numerical can be asked on this based on NCERT. It's not possible for me to solve, but you can look up at that formula. So copper sulfate is electrolyzed using platinum electrodes. Current is given and time is given. How much mass of copper will be deposited? Write the cathodic reaction. Calculate electric charge passed, mass of the copper used. So you can use the Faraday's laws of electrolysis again based on NCERT. So my dear students, this is the first lecture which are given on electrochemistry, and lot of questions are asked in every competition on electrochemistry. Numerical are very important. As I've already told you, I cannot solve all the numericals here, but you can use your NCERT textbook for solving the numericals. Be sure of the units, be sure of these formulas which I have told you. Nernst equation, delta G minus NV, E0 cell with equilibrium constant, resistance, conductance, conductivity, Coleridge law, and variation of molar conductivity with concentration, products of electrolysis and in batteries, and electrochemical process of iron. Wish you all the best. I will meet you in my next lecture. If you find it useful, you can pass it on to your students and subscribe my channel. I will continue to give you more lectures which are important and topics and questions for board paper 2019 chemistry. Thank you. Bye bye. See you next time.